Hi lads, this video is going to go through how to do the higher level section C-2 question based on the hyperbolic paraboloid. The question tells us the graphic shows a footbridge near Liverpool which is based on a hyperbolic paraboloid. The projections of the bridge are given in figure C2 below. The elements of the hyperbolic paraboloid surface ABCD are extended outwards to form the curved outline loop of the supporting steel structure. Part A is to draw the given plan and elevation of the hyperbolic paraboloid ABCD using the number of elements shown and include the projection of the walkway. Part B, curve ABC is a parabola in elevation with vertex at B. Draw the elevation of this parabola. Part C, project from the elevation the given plan of the curved outline loop and project an end view. Draw the walkway in the end view. And then part D, the line CE is a normal to the parabola at point C in elevation. Determine the focal point and the directrix of this parabola in elevation, and all this in a scale of 1 to 500. So to start this question, I'm going to draw my plan view, which is based on an ellipse. And the width in total, the height of the ellipse from top to bottom is going to be a total of 90. After changing the scales of it. And I go up 45 for the centre. And just take that across as well. The actual length of the ellipse in total is 160. So I step out 80 each side. So for an ellipse you can do any method you want to actually solve the question. You can use your triangle method, your concentric circles method. I'm just going to take the concentric circles method for it. I'll just draw my minor circle in as well. After that, I'm just going to go 30-60 each side. Just extend these lines out here. And go 30-60 out this side as well. What I do is take my points down and across here. Gives me a point there on the curve, second point there, and I can extend these out on the other side and drop these points down here. Give me these 2 points. I have my outside edges here and here. And go 30 degrees down in this corner. Take that point across. And then take out my 60-degree line up here. And take these points up and across. Just draw the rest of my circle in heavy here. And take my last point up and across here. And now I'm going to draw my ellipse in freehand. When drawing your ellipse, make sure to keep it as a free flowing curve. It shouldn't have any kind of edges on or anything like that. It should just keep going round and round and not going in and out or anything. It should be just a natural free flowing curve going all around like that there. What I'm going to do is go over in heavy over the line I've actually made. And making sure to actually get up out of your seat to draw your curve. Don't just stand in the one spot. It's very hard to actually move your wrist around when drawing the curve. You have to keep kind of moving because your wrist can only bend so far when you're actually drawing with a pencil. And it helps keep the curve going at a nice flowing rate as well. Here's the last part then. And that's my ellipse then drawn in plan. With the question I have 4 corners, A, B, C and D. So these 4 corners here. So I have A here, B here, C there and D up at the very top. And I connect them all together then. And they're going to be the edges where my elements are going to be placed. And I can just draw them in dashed like it shows in the question as well. So in this question it actually shows that there are 4 elements along each side. So I'm basically dividing the line into 5 equal parts. So each of these are all equal in length, so I can only have to divide 1 into a number of equal parts. So I can just take that edge out there and step off 1, 2, 3, 4, 5 there. Sorry, it's only 4, so I only step actually to the 4th one there. There's only 3 elements running in. So I can connect this last one here, get my set square. Connect that to corner A. Connect this in here. Connect that in there. And that in there. And there are my 3 elements are actually going to be then. So I need to divide the line up into 4 equal parts. After that, what I can do then is I can take these points down here, because the lines are the exact same length, so therefore the elements will be spread out in the exact same place as well. And then take these points across to hit this line as well here. And then just take these up here to find the exact position of each of the elements. And they'll all connect together then. So for example, these 2 connect here, these 2 connect here, connect there, and then the opposite side. They will all connect there. What I'll actually do then is I'll actually use colour to show them. So for example, I'll just draw them in this pink colour here. Now what I can start to do is I can start to draw my elevation showing the actual elements, and then I'll show how to actually take my points along the outside up as well to draw the parabolic curve. So B and D are going to go straight up here, A goes straight up here, and C goes up here, and I'll draw in my XY line then just up here. from the question, point C is located the equivalent of 15 mil up. So there's point C. Point A is also located the same height, so I can mark it there. And then B and D are going to be a further 64 mil up after that. So just adding on to that there. There's my 64 mil. And just take that across there, and that gives me B and D. So A connects to B here. B then connects to C. And then C obviously goes back to connect to D there behind it as well. So that's what I have so far in terms of that. Next thing I can do is take up my elements. What I'll do is I'll actually label them then. So for example 1, 2, 3 here, 3, 2, 1. Just call these 4, 5 and 6, and then 4, 5 and 6 here. So they'll all actually line up. When I take 6 and 3 up, they're both going to touch at the same point there. You have 6 there and 3 there. And then 2 and 5 are going to be on the same point there. 2 and 5. And then 1 and 4 as well are going to be sharing the same point above. And then 3 and 6 on this side. Two and 5. 1 and 4 there. And then I need to connect them together. So 3 and 6, they connect together there like that. 2 and 5 and 2 and 5 connect together there. And 1 and 4 and 1 and 4 connect together there. And just to show it again, use my colours just to show my points. 2 and 5, 2 and 5, 1 and 4 and 1 and 4. Now in the question it tells you then to actually draw the curve. There's two methods. You can just draw your generic parabola method where you use your rectangle method and then you divide up your sides into a number of equal parts and your base into a number of equal parts. With this we can just extend our elements out as well. So in the question it shows, if I just show for example 4 here, 4 can extend out to hit the ellipse, which is going to be a parabola in elevation at 2 points. A point here and a point there. What I can do is I can take up those extended points and extend out my line as well. So just extend up 4 here. What I do is I extend my element in elevation as well to find where it hits it. So there's 4 there and 4 there. Extends out to that point there. Extends out to that point there. There are 2 points on my parabolic curve. And that's also including 1 as well there, because 1 and 4 share the same points. After that then I can do the exact same for 2 and 5, 3 and 6, 2 and 5, 3 and 6, and eventually I'm going to have a curve going all the way around. So I'm just going to extend out the rest of them now to complete that. So 2 and 5 extend out to there and there, and then I extend 2 and 5 out here as well. That gives you that point there, and this point here, and finally 3 and 6 as well. And 3 and 6 on this side here. So I'm just going to extend up 3, 6 is on the same point. I just extend up 1 if I want. And extend that up there. And it's the exact same idea again. Extend the element out each side. Gives me that point there, and that point there. And now you can see I can actually start to draw my curve in as a result. So it's a bit faster than actually drawing the rectangle method, but if you find the rectangle method easier for that part of the question, you can use that. With this method I'm just showing how to actually use the elements, because in some questions they actually ask you to use the elements to draw the curve. And now just go over heavy then. And that's my parabolic curve completed now in the elevation. All I have to do now is draw the actual outline of the road on the bridge, and then the two slope lines are located at points A and C. So from the plan you can actually see that where these two elements here hit off the lines AD and AB, that's the points where the road are going to be extended out each side. So the road is going to run along that line there, and we're going to use our elevation then to determine how far out it's going to go, just for the sake of the actual question. So we're told we go in then, if we change the actual scale from 12 meters, it comes in 24 mil to this point here, and the line going down from C, it's in 24 there, and in 24 there, and that line and them 2 points are connected there like that, and connected there like that. Where the element extends out here, so that point on the curve, we take that point across to hit the extended line. That gives us the edge here, and we can just take 1 and 4 across there, and that'll give us the same height on the opposite side where them two slopes are. And that in turn also gives us how wide or how long they want the road basically to go, just for the sake of the question. So it goes out as far as there and out as far as there. So now I can draw the road in. And the road is a total height of 32 mil or 16 meters above A. So I measure up 32, and the road is located here. So there's our road going across. And that now completes the actual elevation in the question. So now we have the elevation and plan complete. We can now start taking across our points to draw our end view. So for my end view, I'll just take all of my points up at 45 degrees. So D, I then have A and C here, and B there. Take my XY line across, figure out where it hits, and then take up my points here, and take across A and C there, and B and D there. So point D is going to be here, point B is going to be here, and then point A and C are both going to be there. I can draw on the actual road then. the road across, take the widths of my road up each side, and there's my road in my end view there. And now I need to draw the actual curved surface that appears in between them 2 points. So what you can do very simply is you can actually pick points along it. So what I can do is use my elements once again here. So for example, if I take 5 and 3 from this side here and here, or sorry, 6 and 3, they're on the same one. Take 6 up here and 3 up here. Take 6 and 3 across here. And there are now 2 points on my actual curve. I can then do the same with 2 and 5 now. It's the same as taking 2 and 5 over here as well, because they're all on the same lines. So taking up 2 here, and taking 2 and 5 across here, gives me another point here. And on the opposite side, take 5 up as well, and they share the same height. Gives me 2 more points. And then finally, for 1 and 4 here, I can take across 1 and 4 here and here, up at 45 degrees, and then up to hit my point here and a point here. And now I can start to draw in my freehand curve as well. And just draw it in heavy then. You could also take your elements across well if you wanted to, but just for the sake of the question, I've just taken my points instead. But the exact same idea would be is you would connect all your elements together and it would give you your points as well. And that completes the end view of the question. For the last part of the question, we're asked to draw. So it tells the line CE is a normal to the parabola at point C in elevation, and wants us to draw the focal point and the directrix of this parabola in elevation. So we're told this line here, C, and I haven't labelled just my point E here, and I also have, just that line there. So we're told that line there is a normal. So if that's a normal there, there's going to be a parabola run, or there's going to be a tangent running along that line there, 90 degrees to it. To actually find the focal point, what we do is we extend our C point out, so basically where the tangent touches the actual curve. And what we're going to do is we're going to bisect the angle between this line here and our normal CE, so this angle in between here and here. If we bisect that angle in conics, what we'll find is where it's bisected and it passes through the axis running through the middle, that will give us our focal point. So what we need to do is get our compass, take any distance and swing an arc here and here, just extend it out, swing an arc here and here, just extend this one a little bit further, and with that bisected angle there, it's our central axis. That will give us our focal point. With a parabola, we know that our line of eccentricity is always going to be at 45 degrees. So the distance from the focus to the vertex, which is BD in this case, is going to be the exact same as the vertex to our directrix. So we just basically swing that around there, as they're both going to equal each other. And that will then give us our directrix there as a result. And just label that DD for directrix. And then that completes the question.